Good morning, ChapelCon, and welcome to our presentation on the Chapel Debugger. We are a team of seniors from Western Washington University, and we are excited to share the progress we have made on a debugger for Chapel with you today. My name is Cole Yamamura, and I'm majoring in computer science.
I'm Henry Baker. I'm also majoring in computer science.
My name is Drake Riley, and I'm a cybersecurity major.
And we'd also like to acknowledge our faculty advisor, Dr. Phil Nelson. Dr. Nelson has advised all the groups that have contributed to this project so far and has greatly supported our progress this year.
We have worked together over the past 10 months revitalizing this project and attempting to get it to a foundation that can be easily expanded upon by the groups to come. Since the release of Chapel 1.25, there have been 5 groups of seniors at Western Washington University who have been dedicated to developing a debugger specifically for the Chapel programming language. The debugger itself has gone through several changes throughout the developmental life cycle, but the main focus is to simplify the debugging process and handle Chapel's unique abstraction and multi-locale debugging. Debugging a multi-locale program can be challenging because the code is distributed amongst different locales. This requires the programmer to open individual GDB windows through SSH connections or manually write inline debugging code. The initial iteration of Chapel Debug utilized a graphical interface that automated the process of opening individual GDB windows. It was later realized the main node had access to most of the information required, so the next version of Chapel Debugger condensed everything down to one window that queried the main node for information. However, the GUI added a lot of overhead and complexity, so we switched to a CLI interface that resembled GDB. This not only provided a familiar feel, but also simplified the code as well. Recognizing the benefit of some visualization, we chose to implement a text-based user interface resembling the split window mode of GDB.
So as this project has started to gain some momentum, we felt that it was time to show a bit of the progress that has been made, really with the hopes of getting some awareness to what students at Western have been working on. But more so, we really were looking to interact more with the Chapel community to help fine-tune the sites for future groups and future contributors of the Chapel Debugger. We spent a lot of time in our initial phases just brainstorming and really thinking of features and functionality that we wanted to add. But once we started the development process, we realized that really what the debugger needed was just a strong foundation, and that's kind of what we've dedicated our time to with our time with the project. And now that we have some direction, we figured it would be a good time as we prepare to hand this project off to the next iteration, that we just kind of reach out to the Chapel community and try and get some insight and knowledge and experience from, people who use this on a much more daily basis, and just tap into that wealth of knowledge and use that to help the groups to come to have a better idea of what they can do and have a better roadmap so they can really hit the ground running when they pick it up. So now, as it stands, at this stage, we have the debugger fully updated to the current release of Chapel, Chapel 2.0. This was obviously a priority, especially when we learned about ChapelCon and we learned about the release of 2.0 and the increased stability and everything. That became a top priority to keep the debugger just current and relevant. And then to simplify the compiling process, we had our own custom debug flag that'll be demonstrated a little bit later by Henry. And that just simplifies the compilation process so that we really mitigate the potential for people, hitting typos, typing in that amount of the amount of flags, or simply just missing a flag altogether entirely. And again, those flags make it so that our debugger is able to interface with Chapel, the language itself, and the C compiled code. We've also implemented a TUI, textual user interface, that will also be demoed. And as Cole talked about, that kind of replaces the GUI and allows for a lot more streamlined, simplified, but still meaningful way to monitor the code and debug it. Again, like Cole mentioned before, we tried to emulate GDB a lot for two reasons: the intuitiveness of it, the simplicity of it, but then also to get the familiar feel. And, people who may be familiar with GDB will feel familiar with Chapel Debugger. We also have a printing feature, step and next commands that will also be displayed and demoed by Henry.
So I'm going to give a little demo of our debugger so far. So first, I'm going to compile with the flag that we created specifically for our debugger. On the Chapel website, it suggests a number of flags to improve debuggability of the Chapel program. Here it is. You can see that's a lot to type in every time, so at the very least for our convenience, we've created a flag that should have the same functionality as many of these flags, and we've called it Chapel Debug. So let's go ahead and compile with that flag. And since one of the recommended flags is save C to write the generated C code to a directory, I'm specifying C code save as the name of the directory for this flag. Chapel. And while it's compiling, I'll show you the program that we'll be using to demonstrate the debugger. It's pretty simple. It just distributes two arrays over the locales and then sets the value at each index to the locale ID that it's on, and then it prints the arrays. So now that it's compiled, I'll start up the debugger. The command we use is chapel debug, spelled like this. And then you just specify your executable file and the number of locales, just like you would running the program normally. So what the debugger does is it starts up a number of GDB server instances on the remote locales and then connects the Chapel program to each instance. You might notice that the port numbers are different on each locale, and that's something that we added so you can run the debugger with oversubscribing. Right now I'm on my university's Linux cluster of workstations, but if you wanted to use localhost instead of the remote locales, you can do that too. So now I'll show you some of what the debugger can do so far. We've tried to make it as much like GDB as we could because it's what a lot of people are used to. So you have one window and it displays the output from locale 0, but when you send a command like break or continue, it sends the command to all the locales, so you don't have to type it in on several windows like you would if you were just debugging with GDB. So I'll just break on a line here. You still have to type in the full name of the source file you want to break on, and that's something that maybe we'll pass along to the next group to work on. Another thing with the debugger is that you have to use continue instead of run. If you've used GDB to debug Chapel programs before, I think it's the same. So here we are at line 19. If you look at the source code here, you can see that the arrays A1 and A2 have been created, and each index should be equal to the locale ID. So I'm using 3 locales, which means the indices should be either 0, 1, or 2. And since the regular GDB print command doesn't work, we created a new command for the debugger, and it's called print chapel, or PC for short. So it appears to be correctly printing the arrays, but just to be sure, let's step forward a little bit to where it actually prints the arrays in the code. You can see the output is the same. Another cool thing you can do with the debugger is call a function out of order. So let me just start it up again. This time I'll break on here, on this line, because we're going to call the write a function, and it's the only line of code after the arrays have been created that's not part of the function. So break on line 25. And we just do call write a. And you can see it, you get the output just like you would normally if the function had been run in order. And you can see we're still on line 25, so I can just step in and then step through like I did before. So So the stepping in this example was pretty nice, but it's not always that nice when using the debugger because of the way that Chapel compiles through C. Sometimes the order of execution of the lines gets messed up. So for example, if I broke on line 3 instead, and then I try to step through, you can see it's not exactly sequential. And solving this issue was a little bit out of scope for the time that we had, so instead we started working on a way to make it a little bit easier to see where you are in the code, and that's in the form of a TUI. So I'll give a little demo of that now. So just like GDB, you type TUI enable, and you can see it's a lot nicer to look at when you're stepping through. So yeah, that's all I have for the demonstration. I hope that gives you a little bit of an idea of what we've been working on and where we're at with it.
So one of the main struggles that we had at the beginning of this project was having to sort through huge code bases and all the previous contributions from all the other groups. There were a lot of branches in the repository. It's a bit cluttered. And so as we wrap up our contributions and our time with this project, one of the things that we really care about or that is like near and dear to us is making sure that we hand off something of value to the next group that they can hit the ground running with and they don't have to mess around with so much. And that's one of the big reasons, we wanted to present, we wanted to be here, is to connect back and just get a clearer picture of really the direction that we should be taking this Chapel debugger in order to make something that is useful and that Chapel developers actually want to use. Some of the big key things to achieving that goal that we've already realized is some of the stability, some of the quirks with the debugger, some things we just didn't have enough time to refine with the short time that we've had to work on this. So stability and robustness is definitely a thing outside of just like the base features that we have implemented. Adding more features, hopefully ones that are given by Chapel developers, things that, people truly want, not just adding features for the sake of adding features. And then to really expand on the TUI, the textual user interface, because it does seem like there is a big benefit to meaningful visualization with Chapel, whether that be with something like Chapel Viz or just being able to see where data is, see how the code is being processed. I think there's like definitely a lot of value in that. So just making upgrades to the textual user interface is one of the things that we'd like to outline as something of importance going forward for these next groups. But honestly, we really enjoyed being introduced to the language and to the community. And I believe I speak for Henry and I speak for Cole when I say that this was a it was quite the experience getting to work on this project, working on it together and going, through the trials and tribulations of understanding that and getting familiar with the language that, we didn't have a lot of experience, obviously, with going into it. So it was just like a cool experience. It's super cool to be able to present, and thank you truly so much for all your time and listening to our presentation and for any feedback that's provided. We greatly appreciate it.
All right. Thank you so much, Henry, Drake, and Cole, for that talk. It was fantastic. We do have some questions coming in through the chat already. And again, yeah, kudos to you guys. Fantastic work on this. So if you guys are ready to take some questions, I'd like to read them from the chat. So Oliver asks, what are the challenges slash possibilities of adapting these debugger to use in existing IDEs like VS Code?
Yeah, it's a good question. So we, as a group, we've never
created a VS Code extension, especially for like a debugger or something like that. So I'm not sure exactly the challenges. Maybe Phil Nelson has some more insight on that. But that was an idea that we had. If we had gotten further, if we had more time, that's something that we would have liked to do just to make it more accessible for everyone. But I'm not exactly sure about the challenges. But that's definitely something we'll make note of for the next groups to keep in mind.
All right, cool. Daniel asks, when running code out of order via call, as you showed in your demo, can you control what locale you're running on?
At this time, you can't, but that would be easy to implement with the way we've set it up. Because right now it's just getting output from the main locale, but you have access to all the locales in the code. We just didn't get to being able to switch which one you're on.
And
Mhm.
switch to the right from that.
Mhm.
Because yeah, we originally had a function that we were working on for switching locales, but then we transitioned to implement the textual user interface over that as we felt that that was maybe a little more useful at the with the time that we had remaining.
Okay, cool. Also, Daniel has one more question. Can you put breakpoints inside something like a for all loop?
I believe that you can, and I believe we've stepped through for all loops before, but we haven't spent an extensive amount of time testing that. There's a lot of features that we could have tested, but we spent more time implementing these features, and maybe testing would be a project for a future group.
All right. Yeah, that sounds reasonable and right. It's hard to test all the features and edge cases when we're just developing. There's one more technical question from Jade. Can this tool inspect individual locales, similar to how GDB or LDB can inspect individual threads?
Mm-hmm. Yeah, just like running or controlling which locale you're on with call, it isn't implemented, but it would be pretty easy to implement. So that's definitely something that could come in the future.
Cool. I also have one question. Through the call feature, is it limited to just functions which don't take arguments, or can they also take arguments but or like can't be generic or something like that? Because I'm thinking there are probably some limitations on what you can call out of order, right?
Yeah, that's a great question. And we did run into some issues when calling functions, like if the variables haven't been completely initialized, it would just say default and crash the whole thing. So there are definitely some limitations, and we haven't tested that specifically, but I would assume there might be some problems with that. But that's another good thing to test.
All right. Thank you so much. One final question that's more meta is Jade says, I would love to start using this tool and integrating it with other Chapel tools. Is this debugger available to be used now?
It's currently in a private GitHub. Nelson should have developer access to providing code and integration to other GitHubs and code storage. So we will see what we can do in order to pass that on to the Chapel community.
Yeah, Dr. Nelson, is this code able to be made available, or is it still private? Oh, I think you're muted.
Yeah.
We can make it available. We haven't actually worked hard at trying to be able to provide a patch to the Chapel GitHub, but I think that's one thing that we can certainly work on making it available once we let everybody know. We hadn't let really many people know this was here, and we were wondering, we wanted to get it to a certain point where we actually had some functionality people might want to use. And I think that's why we're here, because we finally hit that point after 5 groups. We finally managed to get a point where we might have something that somebody might actually want to use. So I think this might be something we can do in the near future, is try to get it into GitHub.
All right. Sounds fantastic. Thank you. I know we're out of time for this talk. So if there are any more questions that people come up with, we can defer them for later during the break.